Hello, and welcome to the third uRTcmix tutorial, the RTcmix computer music language inside the Unity game and VR development environment. In this tutorial, we're going to be talking about using RTcmix score information inside Unity C# scripts. So let's get started. All right, I've gone ahead and set up the Unity environment by bringing in the uRTcmix Unity package and dragging the RTcmix main object up here so we have access to the RTcmix functionality. Now, just for fun, let's add a few objects to this one. Let's create a plane so we can see where we are. And let's add a sphere. Put it right there. Bring it up a little bit. We're not really going to use these objects too much. I am going to put the RTcmix process on the sphere game object so you can see how you can associate particular RTcmix instantiations with particular game objects. So let's do that. Select our sphere, add a component. Go down here to New Script, and we'll call this Sphere Sound. Okay, there we are. Let's go ahead and edit that script and add what we need to get RTcmix to happen. So we'll open up our C# community editor here, and the first thing I'm going to do is I'm going to add a using system command or instruction at the top. This will give us access to the C# string functionality. RTcmix score information is represented inside these scripts as strings, and we're going to need that in order to do what we have to do with RTcmix. So let's now go ahead and fill it out. Let's do it by hand rather than using the stuff from the uRTcmix template or the beep game object. First thing we're going to do is we're going to declare an int, calling it obj no. We're going to set that to be 0. This is the number of these particular RTcmix instantiation that we're using on this game object. Now, we'll also create another variable that's of type RTcmixMain. We'll call this RTcmix. This is how we'll access all of the functions that we need to make the sound happen. And finally, we'll declare a Boolean variable called didStart, and we'll initially set that to false. This will protect us against trying to do processing before RTcmix is initialized. Typically now we do a void awake and we set the RTcmix main variable equal to, we look for the RTcmix game object, and we do this with all kinds of stuff attached. But we're going to do it a little bit differently this time. Rather than doing it in code, we're going to do it kind of the Unity way. We're going to declare this as a public variable. Now if we do that and we save our script, go back out into the Unity editor environment and wait for it to compile, select sphere, and look down here where the script is listed as the components of this sphere, there's an RTcmix slot that said it's looking for an RTcmix main. Well, in order to get that to happen, we just simply grab our RTcmix main, bring it over there, and plop it in the slot. At this point, it's ready to be used inside the script. Simple. Let's use it. So the first thing we want to do is in the start method, we want to initialize it. So we say init RTcmix, give it the object number that we're dealing with, and now we're ready to go. So we set didStart equal to true. Now we're not going to use update for anything this, so I'll get rid of that, but we do need to fill out a couple of other functions. The first one is the onAudioFilterRead function or method, where we initially check to see if we've been initialized. If didStart equals false, if it hasn't been initialized yet, we simply return out of the method. If it has, then we want to run RTcmix. And to do that, we need to give it the data array that's coming in to this particular method. We give it the object number, and we give it a flag. In this case, we say 0. That means we're doing synthesis only. If we set it to 1, we'd be doing both signal processing and synthesis. It's just a matter of efficiency. So that's ready to go. Next thing we do is add our onApplicationQuit, where we set RTcmix to null, and we set didStart to be now false. This is ready to go. but it's not going to make any sound because we're not sending any RTcmix score information. Now in the past few demos, we sent that information by saying RTcmix.sendScore, and it takes a string, and in this case, we'll just say string wavetable like we had before, say maybe 3.4 seconds long, 20,000. Let's make it maybe 789 hertz. Send it to Obgeno. And this should work. Let's test it. Go back out here. There's going to be a problem. Okay, I'm going to leave this problem in here because I do this a lot and it's probably instructive for other people to see why this will not make sound. If I hit play and it starts up the Unity game, you don't hear any sound. That's because I need to designate the sphere object as an audio source. Go to audio in your add component, say audio source. This now tells Unity that somewhere on the sphere object we're going to be making sound. In fact, we're going to be making it right here with our sphere sound script. Once you've designated it as an audio source, then you can hit play and you should hear the beep. Okay, thrilling. Now, that's all well and good, but this is a little bit tricky if you get a more complicated score. Well, one way of dealing with that is to declare the score somewhere else. We're going to say it's a string, score equals that. So now we've kind of separated out the score kind of string definition from the function that actually uses it. However, I'm not going to go through making the beep again. Trust me, it works. This gets a bit problematic if the score starts getting a bit more complicated. In fact, what I've done is I've created a little granular synthesis score. There it is. And it sounds like this. Very simple, very straightforward. Okay? How do we get that score information into our script? Well, heck, we're defining the score right here. Why don't we simply grab the text of the score? There it is. Copy it out. And simply say score equals that text. Oh my goodness, all kinds of bad things happened. Look, C# is saying it doesn't know what these sort of variables are. That's because this isn't a well-formed string. First of all, C# strings don't like carriage returns. What you have to do is use the concatenation operator and concatenate the next line with this line. Okay, there's something else wrong here. Notice that there's some quotation marks in here. It thinks the string goes from there to there. So we have to escape those quotation marks, okay? Oh, and I'm not very good at typing. It's a problem area. In fact, this is just a real pain in the butt because I'm going to have to do it for the rest of this, okay? There's a better way. I'm going to show it to you, but I want to point out one thing. Notice that I left a little space here and a little space here. That's because when I use that concatenation operator, it will simply glom this next line onto that one. And if I didn't have a space there, it would put the amp-env right there, which isn't good. Well, let's get rid of this nonsense. Okay? And think to ourselves, if only there was a way that we could pre-format that string and bring it in. Well, it turns out that there is. Okay? Let's go back out and we'll copy this time. I'll show you. I'm hitting Command C. Let's copy our score information and let's look out here. And there's this great command that you can download called the Scorealyzer. Works for both Windows and Macintoshes. And if we double click on it, it brings up this little window, not very elegant, but it works. Paste in your score and then hit return and type Control D. So I paste it in, hit return, type Control D, and look, it made a C# formatted score right there. All we have to do is select between the dotted lines, go back out here, paste it in, and let me indent this a little bit so it looks a bit nicer. And now it's got our score variable set to a properly formatted, with the spaces, with the escapes and everything, set of RTcmix commands. And then we can simply send that score with the RTcmix send score. Well, let's do it. If this worked properly, we should hear a nice granular sound. It's got to compile first. Now we hit play, and starting up Unity, and there we go. Yay! We can play it again. And that's wonderful, but it's still a little bit problematic. Suppose we're doing a lot of editing on this, or suppose we have a whole bunch of different scores that we're sending from different places in our code. This is going to be a little bit tricky to try to deal with, especially if the score starts getting very long and complicated. You'll have a huge chunk of this in your C# code. If only there was a way to get the text file itself inside our environment and access that information directly. Well, it turns out there is. What we can do, let's go back to our editor here. What we can do is add another public variable that we're going to call a text asset. We'll call this score text. Now, what this means is that this public slot, go out here and we'll let it compile. This public slot is going to be looking for a text asset. So it's going to be a text file inside our assets of the Unity editor. See, it's looking for it, doesn't find any there. Go back out here and notice that our granular file that I've been using was set up with the .txt extension. That means it's a text file to Unity. So if we drag that into our assets, it's now added as a text asset. And we can simply take that. First of all, the nice thing is we can edit it from within our C# editor, so we can go back and make changes here and it'll be hopefully reflected there. How is it reflected there? By taking this text file, dragging it up to where it's looking for our text asset, plop it in, there we go. Now, if we go back out to sphere sound, we can get rid of this and we can access the text, the string on that score text. Well, score text as a text asset has a lot more to it than just the string, but all we want is the string. Okay, we want string, and we'll call this score string, is going to be equal to the score text dot text. That will bring the text associated with that text asset, turn it into a character string, and assign it to that variable. So now we can use this variable here, string, save it. If we go out, wait for it to compile, and we should hear again the granular sound. Here it comes. Yay! Okay. Now I want to do one more thing before we end. Let's make this be repeating using that max bang technique that we talked about in the last tutorial. So let's go to granular text. Let's add a max bang. And we're going to add it at start because look what happens. The start variable is set to 0. As it unrolls the 20 little granular notes, it adds a certain amount to start each time. That's how it's getting the notes laid out in time. What this means is, though, that when it exits this loop, it is set to when the next note should start. So if we re-trigger the script, it'll continually kind of cycle this over and over again and make a continuous granular sound. So let's go out here, okay, and let's check in our onAudioFilter read. We'll say if RTcmix.checkBangRTcmix, if that, for our obj_no, if that is equal to 1, that means it saw a bang. Then we can simply resend that score. However, notice this is underlined in red. That's a signal that C# editor doesn't like it. That's because we've declared this score string variable up inside this start method. That means it's only active inside that start method. It's called scoping. What we're going to do is we're going to take this and we're going to copy it out and put it up here so that this is now active throughout the entire Sphere Sound class. So we can access it inside start. In fact, let's do that here. Score string equals score text. And we can access it down here in the on audio filter read. Okay? So let's go back and get this to run, and hopefully it will be happy. It looks like it's compiling everything. And now when we hit play, we should hear continuous granular sound. There we go. Okay, so I'll stop it here and say thank you again for watching and listening, and stay tuned for more uRTcmix demo tutorials in the future. Bye.